Okay. In the last video, we discussed analog cellular systems of the United States. In this video, let us discuss development of analog cellular systems in other countries and digital cellular systems all over the world. Let us see analog cellular system development. Let us see, let us see analog cellular system development in Japan. Nippon Telegraph and Telephone Corporation (NTT) developed an 800 MHz land mobile telephone system and put it into service in the Tokyo area in 1979. The general system operation is similar to the AMS system. It accesses approximately 40,000 subscribers in 500 cities. It covers 75% of all Japanese cities, 25% of inhabitable areas, and 60% of the population. In Japan, 9 automobile switching centers, ASCs, 51 mobile control systems, 51 mobile control stations, 465 mobile base stations, and 39,000 mobile subscriber stations as of February 1985 were noticed. The Japanese mobile telephone service network, okay, in this I have not given the figure. In metropolitan Tokyo area, about 30,000 subscribers are being served. The 1985 system operated over a spectrum of 30 MHz. The total number of channels was 600 and the channel bandwidth was 25 kHz. This system comprised an automobile switching center ASC, a mobile control station MC, a mobile control station MSC, a mobile base station MBS, and a mobile setup by the government. However, the Japanese Ministry of Post and Telecommunication MFT was considering providing a dual competitive situation similar to that in the United States. Next, let us see the development in the United Kingdom. In 1982 June, the government of UK announced two competing national cellular radio networks. The UK system was called TACS, Total Access Communication Systems. The total number of channels was 1,000 with a channel bandwidth of 25 kHz per channel. Among them, 600 channels were assigned and 400 were reserved. Two competing cellular network operators, Cellnet and Vodafone, were operating in the UK. The Cellnet system started operating in January 1985. Cellnet had over 200 cell sites covering 82% of the UK. Vodafone, though Vodafone started operations late but has served the same areas as a Cellnet, that is 28 analog cellular systems. Next, let us see Canadian system. In 1978, a system called Aurora was designed for the Alberta Government Telephone (AGT). The system provides province-wide mobile telephone service at 400 MHz. Ongoing developmental work on the Aurora was underway at 800 MHz. Aurora 400 system. It was aimed at 40,000 subscribers living in an area approximately 1920 km by 960 kilometers. The Aurora 400 system initially had 40 channels and was expected to add an additional 20 channels with the frequency reuse and a 7-cell cluster plan. A fully implemented system had 120 cells. The 400 MHz system did not have a handoff capability. Aurora 800 system. The Aurora 800 system was truly frequency transparent. By repackaging the RF sections on the cell site, the mobile unit could be operated on any mobile RF band up to 800 MHz. The handoff capability was to be implemented in this system. Nordic system. This was built mostly by Scandinavian countries. This was built mostly by Scandinavian countries, Denmark, Norway, Sweden, and Finland, in cooperation with Saudi Arabia and Spain, and is called the NMT network. It was a 450 megahertz system, but an 800 megahertz system was to be implemented soon. Since the frequency transparent concept as the Aurora 800 system was used to convert the 400 megahertz system to the 800 megahertz system. The total bandwidth was 10 megahertz, which had 200 channels with a bandwidth of 25 kilobits per channel. This system did not have handoff and roaming capabilities. It also used repeaters to increase the coverage in a low traffic area. The total number of subscribers was around 1 lakh. Next, let us see European cellular system. All the prevailing generation of European cellular networks was totally lacking in cross-border compatibility. Besides the United Kingdom and NMT networks, the others include the following: Benelux country network, the Netherlands. The Netherlands served on their ATF2 network in the beginning of 1985. It has nationwide coverage using 50 cell sites with two different cell sizes, 20 and 5 kilometers 20 and 5 kilometers radii. The capacity of the present system was the capacity of the prevailing system was 15,000 to 20,000 subscribers. Dutch PT&T was using a single Ericsson AXE10 switch. Luxembourg, Luxembourg came on air in August 1985. Luxembourg came on air in August 1985. In 1986, Belgium joined the network and it operated at 400 megahertz. The network was compatible among the three countries. Next, let us talk about development in France. A direct dial car telephone operating at 160 megahertz could access the system in 10 regional areas. The network served 10,000 subscribers. The network served 10,000 subscribers. By the end of 1984, 450 megahertz was in operation. In the meantime, Redicom 2000 digital signaling was introduced, operating at 200 megahertz but with no handoff feature. Next, let us talk about development in Spain. It used in NMT 450 megahertz cellular network introduced in 1982. It was first cellular system in Europe. The number of cells in service was 13. There were three separate networks operating 104 channels. Each of the bandwidth of each was 25 kilohertz. Next, let us talk about digital development of digital cellular systems. In 1992, the digital first cellular system, GSM, was developed in Germany. GSM is a GSM is a European standard system. In the United States, an NA-TDMA system, IS-54, and a CDMA system, IS-95, had been developed. NA-TDMA was developed in 1993, and CDMA was planned for deployment in 1995. A Japanese system, PDC, a Japanese system, PDC, personal digital cellular, was developed in Osaka in June 1994.